Hello viewers, welcome to my channel AK Concepts of Electrical Engineering. Propagation constant gamma, attenuation constant alpha, phase constant beta. If you consider traverse electromagnetic wave in a general medium, if the medium is free space, there is no loss of power during the propagation and hence there is no attenuation. But if the medium is other than free space, there is ohmic resistance loss and consequent attenuation. The medium of propagation of the wave may be a good conductor or a good dielectric or a perfect dielectric. A good dielectric is a dielectric with low loss of power and a perfect dielectric is totally loss free. Now consider general wave equation obtained earlier for electric field, that is del square E equals to mu sigma dou E by dou T plus mu epsilon dou square E by dou T square. This we can write it as del square E minus mu sigma dou E by dou T minus mu epsilon dou square E by dou T square equals to 0. Let this be equation number 1. Let us assume that dielectric field varies cosinusoidally with respect to the time. That is E equals to E naught e power j omega t, where E naught is peak value. Differentiating with respect to t, you'll get dou E by dou T equals to E naught E j omega t j omega. That equals to j omega. This value is nothing but E again. Again differentiating with respect to t. Now I get dou square E by dou T square equals to j omega E naught e power j omega t, again j omega, which equals to j square omega square E. This value is nothing but again E. Now where j square is minus 1, so this we can write dou square E divided by dou T square equals to minus omega square E. Now substitute dou E by dou T, dou square E by dou T square in the equation number 1. We'll get del square E minus mu sigma of j omega E minus mu epsilon minus omega square E equals to 0. Then del square E minus j mu sigma omega E, minus of minus is plus, mu epsilon omega square E equals to 0. Now this equation we can write as del square E minus j mu sigma omega E minus j square mu epsilon omega square E equals to 0, from which del square E minus, I'm taking E out, common is j mu omega sigma plus j epsilon omega equals to 0. And this equation I can write as del square E minus E gamma square equals to 0, where gamma square equals to j mu omega sigma plus j epsilon omega, from which gamma equals to square root of j mu omega of sigma plus j epsilon omega, and this is known as propagation constant. Let gamma equals to alpha plus j beta. That is, alpha is the real part, beta is the imaginary part. Alpha is known as attenuation constant and beta is known as phase constant, in which alpha accounts for the reduction in the amplitude of the wave as it progressively travels through the medium, unless the medium is absolutely loss free. Attenuation does occur, and as the wave progresses, there is increased reduction of amplitude. And beta takes into account the difference in phase which occurs between the wave at the starting point and the wave at any other point at later times. Units of alpha is Napier per meter, and units for beta is radians per meter. Now consider the general equation for wave motion. this can be written as dou square E by dou t square minus gamma square E equals to 0. Let the wave be assumed to be traveling in the positive x direction. Then the electric field E has no component along the x and z axis. So Ey is equals to E, that equals to Ey Uy. It implies dou square Ey by dou t square minus gamma square Ey equals to 0. Let this be equation number 2. Now we know that dou by dou t equals to d, dou square by dou t square equals to d square. Then this one is dou square minus gamma square of Ey equals to 0. Ey is not equals to 0, so dou square equals to gamma square, or d equals to plus or minus gamma, that is propagation constant. Now a possible solution for this equation is Ey equals to E1 e to the power of gamma x plus E2 e to the power of minus gamma x, where even E2 do not vary with respect to x, but that can be a function of time t and they are constant. Then let E1 equals to E1 dash e to the power of j omega t and E2 equals to E2 dash e to the power of j omega t. Ey equals to E1 dash e to the power of j omega t multiplied by e to the power of gamma x plus E2 dash e to the power of j omega t multiplied by e to the power of minus gamma x. Then Ey equals to E1 dash e to the power of j omega t, and e to the power of gamma is nothing but alpha plus j beta of x plus E2 dash e to the power of j omega t and e to the power of alpha plus j beta x minus, in which the first term represents a wave traveling in negative direction and the second term represents a wave traveling in positive x direction, and hence we shall consider the second term, that is Ey equals to E2 dash e to the power of j omega t e to the power of minus alpha plus j beta x. Now this we can write E2 dash e to the power of j omega t minus alpha x minus j beta x, that equals to E2 dash e to the power of minus alpha x e to the power of j omega t minus beta x. By studying this equation, you can say that the wave traveling through a general media gets attenuated by the factor e to the power of minus alpha x. As x increases, it can be seen that Ey is progressively decreases. Hence, the name attenuation constant for alpha. Now, velocity of propagation, that v equals to omega by beta, where beta is the phase constant. Now, gamma itself is termed as progressive constant.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.